Let's move on to the part 3 of AC bridges. Previously we were discussing Hayes bridge, which was a modified Maxwell's bridge. This was the phasor diagram and this is the circuit. Now what we are doing is we are discussing the advantages and disadvantages. Okay, it is good for measuring inductance of the coil if the quality factor is greater than 10. Okay, if you are having a high quality factor of the coil, then this method is rather preferred. It has simple quality factor equations. Okay, you see this equation over here, it is very simple to be solved manually. Then we have low R4 is required. Okay, you see the resistance over here, the value of this is rather low in nature. Okay, you need not to have a very high resistance or anything. The low value is okay for this bridge to be balanced and finding out the unknown inductance of the coil. Then we have certain disadvantages, which are the supply frequency should be known. Okay, the supply what you are using over here, its frequency should be known. Then we have it is not suitable for quality factor less than 10. However, this method is very good for finding out the inductance of the coil whose quality factor is greater than 10, but this method is not preferred if your quality factor is less than 10. This is all about the Hayes bridge. Now we are starting off with Anderson's bridge over here. Okay, it is the modification of Maxwell's inductance capacitance bridge over here. As you see, this is the circuit of Anderson's bridge. Now it is modified version of Maxwell's LC bridge. Okay, LC bridge over here you can see we have studied this in part 2. You see the capacitor is applied over here, but in Anderson's they are applying capacitor across these two terminals over here. Okay, this capacitor is not attached here but rather here in Anderson's bridge. This is what the modifications they have done. Okay, you see the capacitor is not across this arm but it is between this and this. Okay, now okay, this is your required circuit. This is your unknown impedance arm. Okay, this is your unknown inductance over here. What you're going to do is first we are balancing the circuit, the bridge over here, and these are the equations for the unknown things. Okay, here the R1 is unknown, you can find out using this particular formula. Yeah, L1 is unknown, you can use this particular formula. This is your concerned phasor diagram. Okay, you need to practice this very well. Then we have bridge is balanced at E. Here you see this is the point E over here in the middle. Okay, this is the balance point. Converting this delta BEC, here you see this is in delta. We have studied star delta in electric circuits, you can check that video out. Okay, this is star delta conversion over here. We are converting this particular delta into star, then this particular circuit is modified as this. Okay, on converting that delta into star we get this. Okay, here you see this, and this is converted into this. Then we have following observations. Okay, the V1 is given by this formula, V3 is given by this formula, V4 is given by this formula, and so on and so forth. Okay, here you have V1, V3, V2, V4. Okay, this voltage over here, voltage between the nodes. If they are asking in the question to find out the voltage between this particular arm or this particular arm in the question, if it is asked, you can easily use these formulas. Then here are some advantages of this Anderson's bridge, which is fixed capacitor is required. Okay, instead of a variable one. Previously we were using capacitance that was variable in nature. Okay, previously, as you can see here in Hayes bridge we were using a variable capacitor. Okay, in Maxwell's inductance capacitance also we were using a variable capacitor here as well, but here you need not to use a variable capacitor in Anderson's bridge. Okay, here you see the capacitor is not variable, so this is the advantage, because we have also studied that this variable capacitor is expensive. When it comes to here, you can see this is expensive. Here you see variable standard capacitor is expensive, but we are not using a variable, we are using a constant capacitor. Okay, a fixed capacitor over here. This is the advantages. Okay, then we have it is accurate. This method, Anderson's bridge, is accurate. Then we have self inductance less than 1 can be measured. Okay, self inductance of quality factor less than 1 can be measured. Then we have certain disadvantages, which is complicated balanced equation. Here you see, on balancing you get a equation which is somewhat complicated. Okay. Then we have complex design. As comparing to all the bridges we have studied so far, it is having a rather complicated design. Then we have additional point E makes shielding of the bridge difficult. Okay, this point has been added. In other bridges we were not having a this particular point E, but here we are having, so this is creating some issue. Okay, then we are moving to Owen's bridge, and I shall be discussing this in the next part.